Now we will start with the hexa meshing of the same geometry. So just double click on the tjunction.prj, it will open all the files. I would recommend to unload the mesh file, as this will hamper our progress and it will give us difficulty in rendering the geometry. And also we are going to make the new mesh, that's why it's not needed at all for this case. Save this project as a Tjunction Hexa. Okay, now we need to make some splits. One over here, second over here, and third one over here. Delete the extra blocks. And now make the associations. So all four edges and the circle. So do it for the all the three sides of the pipe, two inlets and the one outlet. Now just display the surfaces and click on the snap vertices, apply. Also we will also associate these four edges to this intermediate or intersection circle. Also move them. All right. You can get the sizes from the sizes we already set on the mesh part. So just need to use this tool. Click on apply. And in the blocking, click on the pre-mesh to check the pre-mesh quality on the surface of the geometry, and it looks fine. You can also run the scan plane to check the internal quality of the mesh, but you need to uncheck the pre-mesh. So this seems also okay from this side. This is also okay. Okay, now next step is to make the O grid. Choose all the blocks and choose three faces on the pipes, inlet and the outlet. Click on apply. Again update the size. Click on the pre-mesh. Now we need to change the size manually, so make it 10. So arrow is pointing from this side to this side, so it means that the side 1 is this one and side 2 is over here. So I will change the size on the side 1 or the spacing 1, and the ratio is 1.1. Apply. Also click on the copy parameters to all parallel edges. Right click on the pre-mesh and recompute. This mesh seems okay, then click OK. Otherwise you can change the number of nodes maybe to the 16, and this size maybe as 0.00005. Right click and recompute. Okay. Also change the sizes over here, make it 24. Right click and recompute. Okay, make it 20. Also here 20, right click and recompute. Here make the size equal to number of nodes 12, recompute. Yes. Okay, now we need to match the sizes at these edges so that we get the uh, similar sizes when the blocks are when there is a transition between the blocks. Also repeat this one over here, and then finally use the magic spacing command to make them apply on all the edges. Okay, also apply here. Right click on the pre-mesh and recompute. Okay, now make the sizes uniform over here. Then again check the pre-mesh. Okay, if this is not working, then you can change the sizes from these edges to these diagonal edges, but what we need is that the sizes should be the same on when there is a change in the blocks. So here you can change the number of nodes, 8, decompute. This is not good, then make it 12 again, or you can also change the sizes over here. Twenty-two, and recompute. Okay, also change the sizes on the wall, make it 22 or 24. Okay, here size need to be changed, make it same as these edges have, 22, 22. Okay, you need to fix them at the proper location, so I need some points here. Point 7.5. Okay, now again make the points at the 50% location of these edges, so we'll get the intermediate points over here. Now these are the points where we should be moving them. But before that, I would recommend to merge the blocks. Just move the O grid and now make the use of the tool association to move them at the proper location. Okay, we need some more edges here, so we can put the points over here. Okay, no problem, we can get the new points at these locations. Okay, now display the edges and apply the same operation. And same is true for these edges. Okay, now again make the association for these edges, for these vertices, so we'll get the perfect square. Now because we don't want that these vertices should be associated to the points on the circular curve, so again change them to the curve association. So just choose these vertices and choose these all curves, and similarly over here choose these 4 vertices and these curves. Alright, now check the mesh. Okay, again associate the edges to the curves. Again check the pre-mesh. Okay, now we will use this augured feature. Select these 3 faces. Update the sizes. Over here change the size to the 20. Make it 14.005 1.15. Apply, and here make it 20. 22, 22, 20. Okay, now check the pre-mesh. Also match the sizes over here, so I will use this edge, again the same edge for this side. Okay, make it 1.05. 1.05, recompute. So this case is now ready. Convert this mesh to the unstructured mesh and repeat the steps of the source selection etc. Boundary conditions, they should be there. If not, then yes, they are there. Accept and then output the mesh. Now read mesh the in Fluent. You put the name as Tjuction Hexa. Okay, change the energy equation, turn on, and viscous as K epsilon, realizable, scalable. Okay, also check the quality, report quality. Now its quality is way better than the previous mesh, the 0.57. And the boundary condition in the inlet Y, put the velocity equal to the 0.1, temperature 25, and here is the 0.1. okay, inlet Z, put the thermal equal to the 20. Sorry, first change the units of the temperature. So 25. For the inlet Z is going to be the 15 degrees Celsius, and the velocity here is a 0.3, diameter is 0.15. The velocity here is a 0.3, yes, 15. The velocity is 0.1. Hydrogen diameter is also 0.1 and 25 degrees Celsius. At the outlet, thermal is 20. It's also a 0.15. Solution methods coupled, pseudo transient, solution initialization by the hybrid method, and now run the calculation with the 450 iterations. Now just check the solution on the wall. Okay, temperature. Okay, now just check the Y plus contours. On the walls the Y star, and here is the Y plus, which is changing from the 2 to the 18.217. It means so you can also change the model from the scalar functions to the non-fault treatment, and then continue the solution. Okay, now we stop the solution over here. Check the velocity on this plane. Use the velocity vectors. You can clearly see the modulus is forming on the geometry. Okay, thank you for watching our tutorials.